Okay, so this week we're going to take the equation thing a step further and learn how to represent word problems with equations and use these kinds of diagrams to help us create the equation that we can need to solve it. So here you see three stories with three graphical representations to represent them. In each case, we have to think about why is it that this graphical representation is a good representation for the problem. So before you watch the rest of the video, pause right now and think about it. Why is it that this could work as a graphical representation for the problem? All right, so on May's first example, right, you see that May made 50 flyers. And so you see how the total is 50, represented by this bracket, right? But the flyers were split by 5 volunteers in her club. She gave 5 flyers to the first volunteer. So you see that section right here. 18 flyers for the second volunteer. And 3 remaining volunteers receive the rest of the flyers. So you see how there's actually splitting that in 3 equal sections. So I don't even want you to solve this problem right now. I just want you to see that you can use the diagram to actually represent the problem. If you wanted to solve the problem, you could. Now it would be kind of straightforward. All you would have to do is I realized that the total, 50, right? To make that 50, you must add together the 5, the 18, and the 3x. Now you can actually put these together because that just makes 23. So we will have 50 equals 23 plus 3x. So then you could actually get your equations processed and solve it. You would start by handling the 23 and then the 3. But this is not the point of this problem. That was last week, learning how to solve equations. Here, we just want to know why is it that this diagram works? So pause it before we looked at the next one. Okay, so here again, we have 5 volunteers. Each volunteers to thank them gets the same number of stickers, but then she decides to give them 2 extra stickers at the end. And so total, she gave them 30 stickers, right? So at first, she gave them the same number of stickers, but then decided to give them 2 extra, and that came out to a total of 30. So once again, the bracket represents the total, and then you have the number of stickers that was the same for everybody, but there's 5 sets of that, okay? So see how this diagram can equally represent that story. Now, how would you put that into equation? Well, we have 5 times that y plus 2, right? And that equals to the 30 stickers. And here again, you have an equation that you could use last week's skills to solve. Since this is in the parentheses, you would start by dealing with the 5, and then you would deal with the 2, but you would solve it. Now the next one is one more example of why you could do this. So let's see. We have the number of flyers is equally made another group of flyers that were distributed equally among 5 volunteers. But then she remembered that she needed some extra flyers to give to teachers. So she took 2 flyers out of each volunteer. So you see she has 40 flyers, distributed them equally, but then took away 2 from each. So this is another way to represent that. And again, this would be 5 times y minus 2 equals 40. And then you would try to solve that. All right? So again, the goal of this video was not showing you how to solve it. That was last week. It's just that you could use this little graph to represent a story problem and use that to create an equation that you can then solve using last week's skills. If you are interested in the solutions for these equations, pause the video because I'm about to reveal them after this. So there you go. I have the solutions on the screen. I don't have actually the answers. I don't actually have the way to solve it. I'll leave that up to you to figure out why I got these answers, practicing last week's skills. On the next video, I'm going to let you guys actually practice how to create these graphs yourself so that you can come up with the equations next time you have a story problem.